That's why you're my favorite, Bailey. All right, Ricardo launches a rocket from a balcony. The table shows the height of the rocket after each second of its flight. So, and there's the heights and the times. So part A wants to know, what are the X and Y intercepts? What are the X and Y intercepts? So where does the X equal and what does the Y equal? This is honestly the way I remember it. It's the opposite of what you want. So at the X-intercept, the Y is 0. Where's the Y 0 at? 8. Where is the X 0 at? The X is at 0 at 15. So that's your Y-intercept. Pretty straightforward, not that difficult. All right, you'll see a question like that again today and Friday. So, all right, moving on. What is the X-intercept? What is the X-intercept in terms of the rocket? Intercept. So the X-intercept is way at 8. So what happened at 8 seconds after we launched it? What happened to the rocket? It got higher, got higher, got higher, got higher, and then started getting down, going down, until eventually what happened? It hit the what? The ground. Hit the ground. So it's number of seconds until the rocket landed. I like that. So far, so good. That makes sense. I like stuff that makes sense. What is the Y-intercept? All right, question for someone smart. David, thank you for volunteering. Has the rocket launched at time 0? At time 0. So what does this 15 mean? Why isn't it 0? It is elevated. Very good. It says it's elevated. It's launched from a... Oops, you can't see that. There you go. Launched from a balcony. So how tall is a balcony? 15 feet. That's all it's asking you. So the height of the rocket when launched. The height of the rocket when launched. All right, can I go on? We good? I'll wait. All right, can I go on? Anyone need more time? All right, I'm going to turn my page over. A figure has symmetry if there exists a rigid, we're going going back to geometry. Motion. In this case, it can be a reflection. Translation. Rotation. Or glide reflection. That maps the figure onto itself. And I'll give you some examples of exactly what that means here. So rigid motion, as Mr. Zach, Mr. Trewen, or Mr. Williams would tell you, does it change its size? Does a rigid motion translation change its size? No, it doesn't. It just moves. That's all it means. So it stays the same size and it just moves. It can rotate, which means spin. Reflect means it's flipping over. Translation is just sliding. And let's continue on. Line symmetry. Can be reflected in a vertical line so that each half of the graph maps exactly to the other half. Yes, ma'am. Sign up. All right, so it says line symmetry can be reflected in a vertical line so that each half of the graph maps exactly onto the other half. So if I split it in half, just like this, with a vertical line, is it exactly the same on both sides of the line? Yes, it is. So therefore, that graph has line symmetry. And it doesn't matter where on the line it is. If it splits it directly in half, it has line symmetry. So line symmetry, I can fold it on top of each other and it fits perfectly. Are we good with that? Pretty simple. All right, next, point symmetry. Rotates 180 degrees about a point and excuse me, maps onto itself. This one's a little tricky to draw, but not terrible. So what it means by point symmetry is if I put my pen right here in the center at the origin and I spin it 180 degrees, does the graph look any different than what I started? Nope, it's the same exact thing. I'll prove it to you again. So if I spin it like this, 180 degrees, it's exactly the same. That's all that means by point symmetry. It must be 180 degrees. All right, even functions have line symmetry with respect to the y-axis. So this one here would not be an even function in terms of this because it's not reflected over the y-axis, is it? It's reflected over a point over here. So it must be, I'm going to draw a little graph just to make sure we understand. And it has to be in respect to the y-axis. Does it have to open up? Nope. And this would be an even graph. I'm glad that the hook stayed on because I had to fix it yesterday because it wasn't. And you can get a picture of this in a minute if you need it.
I'm not too good for it, so.
Good point. Valid point. All right, can I turn that over? We good? We're almost done for today, and then you won't have a ton of time to do your homework, but you'll be able to at least get started on it. Chloe, you're kind of quiet today. Is everything okay?
Everything's great. No one's seen you out here.
Oh, I'm sorry.
It's okay.
I can send you to IC. I'm sure there's a lot of people there.
Oh, no.
I'm just looking out for you. I know you're a social
I appreciate it.
person.
I really do.
Odd function. Have point symmetry with respect to the origin. So this was just like our example that I drew for you earlier. When I didn't do it on purple, now I feel shame. I don't know why I like the graph in purple, I just do. I said, I'm sorry, you don't need to throw stuff. All right, so if we spun that 180 degrees, it would be exactly the same. So that is an odd function, right? That's solving it graphically. Can we solve it algebraically using actual numbers? Savannah says yes, and I agree with Savannah. All right, so let's try it. This is our last thing for today. To solve for even or odd, comma, space, plug in the number 1 and -1 for x and solve. I don't know. I think so. That sounds about right.
This is
No, it's
6:21.
6:21, yeah. So they start in the auditorium at 6 and then go to their
20
classes.
minutes, yeah.
Yes. I think they're in there for 15 minutes and then they transition.
Yeah.
Why did you ask me?
Well, because I can't have it.
Okay. We're recording this. Why don't we want it forever? All right. Okay, here we go. If the answers are the same, comma, space, it is even. And for you good avid kids out there, if the answers are the same, it's even. If the answers are opposites. Chloe, what's my answer going to be? So if it's the same, it's even. If it's opposites, it's
Different.
it's
Oh, odd.
odd. Good job, Chloe.
Yes.
It is odd. So if they're the same, it's even. If it's opposites, it's odd. Yelena, what happens if it's different, if the signs are different? What would my answer be? If the answers are different, so if it doesn't come out, one doesn't come out, or if they don't come out the same and then they don't come out, like this one, I mean, if we plug in 1 for x and it comes out to be 2 on both of them, and on this one it comes out to be 2 and -2, what happens if it comes out to be 3 and 1? Then it is not odd, but not even. It is not even, it's not odd, it is neither. Yeah, neither. If the answers are different, it is neither. I think we need an example on that. This sounds confusing. Example 7. This is a lot of examples in this section. I'm sorry, it's not my fault. I didn't write the book. So what it's going to do is give us an equation, or an expression, x cubed minus 4x. So it wants to know if it's odd, even, or neither. So what I need to do is write it twice. I'm going to write it twice. So my directions say to solve for an even or odd, plug in 1 and -1. So wherever I have an x, I'm going to replace it with 1. All right, let's do some advanced math. What's 1 times 1 times 1? 1. -4 times 1? 1 minus 4 is? Perfect. Now we're going to plug in -1. negative 1 times negative 1 is positive 1 times negative 1 is negative 1. You are just giving me the answer. You are a step ahead. That's all. I'm not saying you're wrong, just a step ahead. And what's negative 4 times negative 1? Negative 1 plus 4 is positive 3. So we have a negative 3 and a positive 3. So is that same, opposite, or different? It's opposite, so my answer is going to be odd. There you go. Like I said, it's not super difficult once you know what you're doing. Let's try one more. And if you get this right, we're done for today. What happens if you get it wrong? We're done for today. All right, x squared plus 2, is it odd, even, or neither? And I'm going to come around and collect your schedules. Do you have a parent coming today? It's not big deal. Thank you. Thank you. All right, so we have an answer yet? All right, so the only thing you need to be careful of is this is squaring negative 1, so negative 1 times negative 1 is positive 1. 1 plus 2 is 3. The numbers are exactly the same, so it is even. Yay, I like stuff that we understand.